Good morning. Let's go ahead and talk about section 4.5 today. And section 4.5 is over graph using slope-intercept form. I'm pretty sure this is stuff that you've done before. Actually, I'm positive it's stuff that you've done before. But let's make sure that we review it and that we're all on the same page. Remember when we see this phrase, slope-intercept form, we're talking about y equals mx plus b. It's that format. It's the shape of your or function form, and when we talk about that, we're really looking at the fact that when we see it, we're not really going to see m and b. We're really going to see a y and an, oops, apparently I didn't want to write that y. Y equals, and then a number, and that m value is usually in fraction form. So let's put an example there. Negative 1/2 x plus 7 would be an example of slope-intercept form. And when we look at this and we look at the formal definition, we talk about the fact that we can look at an equation, and when we look at it, we can know its slope because that's the number in front of x. We know slope. And we know its y-intercept. That's that b value. Y-intercept. Just from looking at the problem. Now, I want to put a little note here to you, and I would really like it to be up here, that slope is talking about motion. How does my line move? How does it change, right? That rate of change. And y-intercept is talking about the starting point. And it is always on the y-axis. Now, function form is very similar. It has all the same ideas that I can look at a problem and know a lot about it. Specifically 2 pieces, function form. But in function form, they take, instead of using y, they use this f notation. It's f of x is equal to mx plus b. It's just a name, and it's just a different format for naming it. It allows us to talk about an ordered pair just a little bit differently. So this is a function, its name is f, and we use the variable x when we talk about it. And it's in mx plus b. Parallel lines are the last vocabulary word we need, and I'm going to go with a visual definition. Remember that parallel lines never touch, right? We have an idea of what parallel looks like. Parallel lines never touch. So that they have the same slope. Same slope. Morning. They have the same slope. So remember, that doesn't matter if they're sloped this way or they're sloped this way or they're vertical or they're horizontal. It doesn't matter, that they always have the same slope. And that when they're in slope-intercept form, we could look at them and know their slope. So let's go down here a little ways. And it says, finding the slope and y-intercept. A linear equation of the form y equals mx plus b is written in slope-intercept form. Where m is the slope and b is the y-intercept of the graph's equation. So just like we wrote up above, slope and y-intercept. So on my graph, this m is equal to 2, this b is equal to 1. So we're going to start at the point 0, 1, and we're going to move through the slope. Now, because this slope is positive, I always think of it as being rise 2 every time we move right 1, because that 2 is 2 over 1 as a fraction. And I always move to the right. So I either rise or fall, and then I move to the right. So I graph my starting point, 1 on the y-axis, and I rise 2, 1, 2, and move right 1 to put in my next point. Rise 2, right 1. Now the cool part is once I know which way this graph goes, I can actually work backwards, so I can move left, but down and left. So it's a double negative, which makes a positive slope. Down and left, down and left. And I can connect my dots, and you're going to use a straight edge on your homework as well as on a test or a quiz, so you don't end up with wiggly worms like I have. And I've got to pause and go to a meeting, but I'll come back and finish in a moment.